Hi, welcome to this Blender video tutorial entitled ArrayModifier. One of the many Blender duplication tools is called the ArrayModifier. The ArrayModifier is an object mode modifier that duplicates an object's mesh in a number of array patterns. Unlike Blender's Shift-D duplicate tool, the duplication remains part of the original object. In this sense, it is modifying the original object rather than duplicating it. To demonstrate Blender's array modifier, I've placed a UV sphere object in my Blender scene. I'm in top orthographic view and in wireframe display. With the sphere object selected, I'll click on the Modifier Context button located in the Properties panel. I will then click on the Add Modifier button and select the array modifier. By default, the array modifier is set to fixed count with a count of 2. It is also by default set to a relative offset of 1 along the x-axis. The count, when set to fixed count, determines the number of duplicates. I'll increase the count to 3. The positioning of the duplicates is determined by either the relative offset or the constant offset controls. The difference between the relative and constant offsets is the multiplier used to calculate the offset distance. The relative offset uses the original mesh's x, y, or z dimension as the offset multiplier. The constant offset uses the original mesh's x, y, or z scale as the offset multiplier. To demonstrate this, I will first click on the Delete X in the Modifier panel and remove this array modifier. If we look at the transform characteristics of the UV sphere, we see that this object has a scale of 1 in the x, y, and z directions. We also see that the object has a dimension of 2 in the x, y, and z directions. Now I'll add back in the array modifier to the sphere object. I will set the fixed count to 3. Now by default, the relative offset is checked and the x-axis offset is set to 1. The relative offset uses the original object's dimension as the offset multiplier. Since the UV sphere's original x dimension was equal to 2, Blender multiplies 2 times the x relative offset setting of 1 and offsets each duplicate 2 Blender units center to center. I'll set the x relative offset to 4. Now Blender multiplies the original sphere dimension, which is 2, by the offset number and offsets each duplicate 8 Blender units center to center. I will uncheck the relative offset and select the constant offset, and I'll set the x constant offset to 1. The constant offset uses the original object's scale as the offset multiplier. Since the UV sphere's original x scale was equal to 1, Blender multiplies 1 times the x constant offset setting of 1 and offsets each duplicate 1 Blender unit center to center. I'll set the x constant offset to 4. Now Blender multiplies the original sphere scale, 1, by the offset number and offsets each duplicate 4 Blender units center to center. The offset effect can also be cumulative. Here I will add the relative offset to the cumulative offset. I will uncheck the constant offset and set the x relative offset to 1.5. I'll set the fixed count to 5. The array modifier duplicate offset can be in any of the x, y, or z directions. Here I will add the y relative offset to 1.5. Now the duplicate offset is in both the x and the y directions. Here I will add the z relative offset to 1.5, and then switch to front view. Now the duplicate offset is in the x, y, and z directions. I'll switch the y and z offset back to 0 and go to top view. I'll change the fit type from fixed count to fit length. Here the array will fill as much of a specified length as possible with duplicates given the relative or constant offset settings. I'll set the length to 30 Blender units. Given the relative offset of 1.5, the array modifier makes 10 duplicates to fill as much of the 30 Blender unit length as possible. I will change the fit type from fit length to fit curve. Here the array will fill as much of a specified length of a curve object as possible with duplicates, given the relative or constant offset settings. The curve object can either be a Bezier curve, or a NURBS curve, or a path curve. I will add a path curve to the scene. I'll name this object FitPath. Then I will select the sphere object and go back to the Array Modifier panel. I'll click in the curve box and choose the FitPath object. I'll then select the FitPath object and tab into Edit mode. I'll grab the right end of the FitPath object and increase its length. Now as I do this, the Array Modifier creates more duplicates to fill the length of the curve object based on the relative or constant settings. This is one good method to animate a duplication because the length of a curve object can be animated. I'll tab out of Edit mode and reselect the sphere. I'll change the fit type to fixed count and set the count to 1. It is possible to rotate the array by adding an offset object. This offset object is usually an empty object. It's best, I've discovered, if this empty object is placed at the center origin of the modified object. To do this, I'll select the original sphere object and press Shift-S, which displays the snap menu. I'll select Cursor to Selected, which will place my 3D cursor at the center origin point of the sphere object. I'll then add an empty object, and I'll name it Pivot. Now for this to work properly, both the empty object and the sphere must have the same initial rotation, location, and scale values. Looking at the transform panel, my empty object and my sphere object have the same location, rotation, and scale values. I'll now select the sphere and change the fixed count to 12. I'll click inside the Offset Object box and select the Pivot object as the offset object. I'll then checkmark the Add Offset Object. I will then select the Pivot Empty Object. If I move the Pivot object, the offset and the axis of the duplicates change based on the cumulative effect of the empty object's location plus the relative or constant offset. If I scale the empty object, the scale of the duplicates are changed in what appears to be based on a quadratic scale. If I rotate the empty object, the duplicates are rotated in a curved fashion. I'll do this with some precision. I'll press the R key, followed by the Z key, followed by 30, and then enter. I have thus rotated the empty 30 degrees around the Z axis. I'll go back to the sphere object. We can change the X, Y, and Z relative or constant offset. I will add the Y relative offset to 1.5. I'll then add the Z relative offset to 1.5, and then go to Front View, and rotate my view. We have a sort of helix array here. I'll increase the count to 30. This is perhaps a good time to note again that the array modifier does not create duplicate objects. It creates duplicate meshes. And furthermore, those duplicate meshes are procedural until the Array Modifier Apply button is engaged. I'll tab into Edit mode. Note that only the original vertices are available for editing. I'll box select these center sets of vertices on the original sphere, and I'll scale them out a bit. Notice that the duplicates are changed in the same manner. I'll tab out of Edit mode, go to Top View, and uncheck the Add Offset Object checkbox. I'll set the fixed count down to 5, and set the y and z relative offset to 0. Now, to demonstrate a few practical applications of the array modifier, I've modeled a saw wedge shape on layer number 2. We can use this array modifier to turn this into a circular saw blade. The sawtooth wedge shape is a flat plane shape. I place the shape's origin point to the bottom vertex. At that same point, I've added an empty object and named it sawEmpty. The sawEmpty object and the sawtooth shape have the same origin point location, the same rotation settings, and the same scale. This is critical to successfully using the array modifier's offset object tool. I'll select the sawtooth shape object and add an array modifier. I'll set the fixed count to 48. I'll checkmark the Add Offset Object checkbox and select the sawEmpty as the offset object. I'll then select the empty and rotate it about 7.5 degrees around the z-axis. I'll then go back and select the shape object. And in the modifier panel, I'll change the relative offset to 0. I'll then checkmark the Merge checkbox. This ensures that any overlapping vertices will merge when the modifier is applied. I'll also checkmark the First Last checkbox, which will merge the first and the last sets of vertices when the modifier is applied. I'll then click on the Apply button. This permanently applies the modifier to the object. I'll now tab into Edit mode, and you can see the vertex structure of the saw blade. I'll select all of the vertices and rotate my view a bit, and then I'll extrude the vertices slightly along the z-axis to give the blade some depth. I have another demonstration on layer 3. Here I have modeled a single step unit, and I'll use the array modifier to create a circular stair unit. The step object consists of a dimensional wedge shape step, to which I've joined a short tube object. Now I've placed the origin center point of the step object to the bottom center vertex of the tube extension. At this same location, I've added an empty object named stepEmpty. The stepEmpty object and the step object have the same origin point location, the same rotation setting, and the same scale settings. I'll go to Top View and select the step object and add an array modifier. I'll set the fixed count to 12. I'll set the x offset to 0 and change the z offset to 1. Now the 12 steps are stacked one on top of the other. I'll then checkmark the Add Offset Object checkbox and select the stepEmpty as the offset object. I'll then select the stepEmpty and rotate it about the z-axis about 25 degrees. This creates our circular stair unit. I'll go back to the sphere object on layer number 1. Blender arrays can be stacked. That is, we can add multiple arrays in an object's modifier stack. Now here the array modifier has 5 duplicates along the x-axis. I'll add another array modifier, which is displayed below the first array modifier. I will set the count to 5, and the x relative offset to 0, and the y relative offset to 1.5. We now have 25 duplicates. The first array created the array of 5 along the x-axis, and the second array created 5 times 5 array along the y-axis. I'll add a third array modifier. I'll set the count to 5, and the x relative offset to 0, and the z relative offset to 1.5. I'll now rotate my view. We now have 125 duplicates, with a third array creating 5 times 5 times 5 array along the z-axis. The array modifier is, I think, one of Blender's most useful tools. Many objects in real life are made up of multiple duplicates, and the array modifier provides an easy and effective method for creating and arranging those duplicates.